Find remaining zeros of a third-degree polynomial with real coefficients that have zeros 3 and I. Construct a polynomial with these zeros and write in the polynomial form. Since we are given I, we also know negative I is also a zero because that is a property we learned that when an imaginary number is there, that a zero also has to be always a negative of whatever that imaginary number is. So then in the equation it can cancel out and not be imaginary in the equation. So since it's a third degree polynomial and we know that the zeros are I, negative I, and 3, we now know our zeros. So we can make a equation with them. So we can do f of x equals x minus 3 times x minus I times x plus I. And we can then condense it to x minus 3 times x squared minus I squared, and we know that x minus 3 times x squared plus 1 equals that because negative I squared equals a positive 1. So now we just FOIL and we get x to the third minus 3x squared minus x minus 3 because x times x squared is x to the third. Negative 3 times x squared is negative 3x squared. X times 1 is actually a positive x. Whoopsies. Yeah. X times 1 is a positive x, so it's going to be plus x, and then minus 3 because negative 3 times 1 equals negative 3. So f of x equals x to the third minus 3x plus x minus 3. And that is how you find the zeros of a third degree polynomial given 2 with one of them being imaginary.